Bismillah ar-Rahman ar-Rahim. Welcome to a new lesson in SAT, and our lesson today is functions. Function or functions is divided into a lot of things, or a lot of values, a lot of equations, a lot of method of solving. Functions into SAT is divided into function notation, linear function, quadratic function, exponential, and transformation of a function. Function notations is how we are writing the function as f of x or g of x, h of x, and how we write the equation equal first degree, second degree, or third degree. Linear equation is the equation or the function of first degree. Instead of writing y is equal mx plus b, we are going to write it into f of x is equal mx plus b. Instead of writing m of x plus b, so linear function is the function of first degree. Quadratic function is the function of second degree, and we have a general form for the quadratic function, ax squared plus bx plus c, and we have a vertex form, and we have also x-intercepts form. We are going to know everything in details, inshallah. Then we have the exponential function, and we have two kinds of exponential. We have exponential growth, and we have an exponential decay. Transformation of a function in our studying, we are going to study translation, reflection of a function chart. So today we are going through the function notation, how to replace the function, how to replace a value of x into a function by using a function, by using graph, by using a table. First, f of x or the function f of x is equal to x plus 1. From the definition of 2x plus 1, it's a linear function. Why? It's a linear function because as we can see here, that x is to the power of 1. First question here is to find f of 3. And the meaning of f of 3 is to replace x with 3. So to replace x with 3, it's going to be 2 multiply 3 plus 1. Notice that in this example, the function is given. It's not graphed and it's not a table. So 2 multiply 3 is 6, and 6 plus 1 is equal to 7. Second example, f of negative 2. And the meaning of f of negative 2 is replacing x into the equation with 2. So 2 multiplied by negative 2 plus 1, which is equal to negative 4, plus 1, which is equal to negative 3. Third question, find the k or a or b or c in a constant. So k here represents a constant. In case of f of k is equal to 3. So as we notice here, f of k, it means replacing x with k. So 2 multiplied by k plus 1, and the whole equation is equal to 3. So let's solve this equation together. 2 multiplied k is 2k equal positive 1, subtract 1 from both sides is equal to 2, divided both terms by 2, so k is equal to 1. So again, there is a big difference between f of a number and the meaning of f of a number that I'm going to replace x with this number. And f of a constant is equal to a number, it means that the whole equation is equal to a number, and the number here was 3. Another example to clarify it for you, if f of a, where is a is a constant, is equal to negative 5, find the value of a. So I'm going to replace x with a, so 2 multiply a plus 1 is equal to negative 5. Subtract 1 from both sides, so 2a is equal to negative 6. Then divided by 2 both sides, so a is equal to negative 3. So again, there is a big difference between f of a number, like for example 2, and f of x is equal to 2. First one, I am replacing x with 2, but the second one, I make the equation is equal to 2. The second part for the same function, I wanted to find the x-intercepts. And I mean by x-intercept the points where the function intersects the x-axis. And to intersect the x-axis, I will replace y with 0. And I mean by y here that f of x should equal to 0. So I'm going to write that 2x plus 1 equal to 0. I make equality of the equation equal to 0. So 2x is equal to -1, divided both term by 2, so x is equal to -half. So the x-intercept of this graph or this function is negative. So if I'm looking for x-intercept, I'm replacing y with 0. But what if I'm looking for the y-intercept? The point intersect the y-axis. So in this case, I'm going to replace x with 0. I'm going to replace x with 0. It's the same as f of 0. So y-intercept, same as f of 0. And f of 0 is equal to multiplied by 0 plus 1, which is equal to 1. If I wanted to write this as order pair, it's going to be -half and 0. But if I wanted to write this as order pair, it's going to be 0 and 1. So there is a big difference between x-intercept of a function and the y-intercept of the same function. Now, another questions on the same function of linear equation or first degree, but the questions, as we can see here, all of them in terms of x. All of them in terms of x. So if I wanted to find f of 2x, it means that I'm going to replace this x with 2x. So 3, open bracket, replace x with 2x minus 4. And 3 multiplied by 2 is 6x minus 4. And as we can see, this is the simplest form. For the second one, I'm going to replace x. So notice that I'm writing x as a bracket, empty bracket, with x plus 1 minus 4. So I need to expand. 3 multiplied x is 3x. 3 multiplied by 1 is 3 minus 4. So I have two like terms. So the answer is 3x minus 1. F of 2x and f of x plus 1 and f of 3x minus 4, we're going to use them later in the transformation. Last one, 3, and replacing x with 3x minus 4 and the whole equation minus 4. Expand is going to be 9x minus 12 minus 4. So it's 9x minus 60. So as we can see here, that the answer is not a whole number. The answer here is a constant in terms of x. Another redirect question. F of x is equal to 3x minus 4, and I am looking for the value of a such that when I'm replacing x with 2a, the answer is a. So I'm going to replace x here with 2a, and I will make the answer is equal to a. Look to the order how I wrote it. So 6a minus 4 is equal to a. By adding 4 to both sides, so 6a is equal a plus 4. And moving a to the other side or subtracting from both sides, so 5a is equal to 4 divided both by 5. So a is equal to 4 over 5. What if I wanted to find f of negative x? F of negative x, it means that I'm going to replace x with negative x. So it's going to be negative 3x minus 4. Now, let's go to another title of studying the function, which is the composite functions. And the composite functions come in the SAT are very easy. Most of it about the numerical values, replacing the values. As we can see at the front of us, I have two functions, f of x and g of x. The first one is 2x minus 1, and the second one is 1 plus 3x. Both of them are linear functions because both of them are first degree. What if I wanted to find f g of 2? It means first I need to find the value of g of 2. So g of 2 is equal, replacing x with 2, so it's equal to 1 plus 6, which is equal to 7. Then I'm going to take this 7 and find f of 7, which is 2 multiply 7 minus 1, which is equal to 13. Again, f g of 2 means I wanted to find the value of g of 2, then I go back and replace it in f. Another example, g f of negative 1. It means first I wanted to find the value of f of negative 1. So it's 2 multiplied by negative 1 minus 1, which is equal to negative 3. Then I go back and I find the value of g of negative 3, which is equal to 1 plus 3 multiply negative 3, 1 minus 9, which is equal to negative 8. So the final answer is negative. But if I'm looking for f of 4, it means that I'm going to replace 4 into the function of f of x. So 2 multiplied by 4 minus 1, which is equal to 7. Then I go back and I figure out f of 7. And f of 7, we just figure it out, is equal to 30. So it's very important to understand the difference between fg of 2, gf of a number, and ff of a number. But if I'm looking for, given the same two function, and I'm looking for gg of negative 2, it means that I'm going to find g of negative 2 first, replacing x here with negative 2. So it's 1 minus 6, which is equal to negative 5. Then I'm going to take this negative 5, replace it again into the function of g. So it's 1 minus 15, which is equal to negative 14. Now, listen carefully how I will find fg of x. And fg of x, it's not a numerical value. I'm going to find the function in terms of x. It's rarely this question comes in SAT, but for you, you should understand it. fg of x, it means you are going to replace the value of g as a whole function into f. It's the same like replacing g of x with 1 plus 3x. So it's 2, and then replace this x with 1 plus 3x, all minus 1. Expand. So it's 1 plus 6x. What about gf of x? Gf of x, it means replace f as a function into g. So it's g, and what is the value of f of x? 2x minus 1. So I'm going to replace this x with 2x minus 1. So it's equal 1 plus, expand. So it's 6x minus 2. So notice for the questions 5 and 6, the value of the f of x and g of x is a function, a new function in terms of. If f of x is equal, a over b, then the function is undefined if the denominator is equal to 0. Again, for any function, especially the fractional function, like x plus 1 over x minus 3, this function is equal to 0 only in one case if the numerator is equal to 0. But this function is undefined if the denominator is equal to 0. If the denominator is equal to what? Equal to 0. So if f of x is equal 5x minus 3 over x plus 5, find the value where this function is undefined. And I mean by undefined here, that makes the value, that makes the denominator of this function equal to 0. So x plus 5 is equal to 0, so x is equal to negative 5. So notice that if you are working with any fractional function, the denominator shouldn't be equal to 0. Another example, if f of x is equal to x minus 3 over x squared plus 5x minus 0, and I wanted to find the values of x which make this function undefined. So I am looking for the values which make x squared plus 5x minus 6 is equal to 0. How I can solve this quadratic equation? You can go back to the factorization video to understand that. I'm going to write it as x and x negative. So one is positive and one is negative. And I'm looking for two numbers. The product is 6 and the difference is 5. So it's 6 and 1. So x is equal to negative 6 or x is equal to negative 1. Positive 1, sorry. So the two values make this function undefined is x is equal to negative 6 and x is equal to 1. The second part for studying the function is to understand the function notation for a given graph of a function. As you can see to the right here, I have a graph function, and I wanted to answer all of these questions from the graph. I don't have a function to replace the values with. First, I'm looking for f of 3, and f of 3 means the 3 as order pair is with what value? So I go to 3 on x, go up until I intersect the function, and I will figure out that the point 3 is with 4. So f of 3 is equal to 4. Again, what is f of 0? And f of 0, it means here the intercept part or the intersection point with y-axis. So where the intersection point with the y-axis is 1. Or because the point is 0 and 1. What about f of 4? F of 4, as we can see, it's intersected the x-axis, so it's equal to 0. F of negative 1, as we can see here, f of negative 1 is with negative 1. But what about f of 1? First, I need to figure out the value of f of 1. F of 1 is equal to 2. So then I go and find f of 2. F of 2 is also equal to 2. So f of 1 is equal to 2. But what about f of 3? So first, I figure out the value of f of 3. F of 3 is equal to 4. So I go and figure out f of 4 here is equal to 0. So all of these values, all of these answers, I figured it out from the graph of the function. Again, from the graph, find the values of k, where is f of k is equal to 5. So here, I will go to the y-axis. So I go to the y-axis to the point 5 and check where the curve is. The curve is at f of negative 4. So k is equal to negative 4. Again, f of c is equal to 4. So I go to 4. The graph is intersect at 3, and the graph intersect at negative 3. So I have two values for c. C could be 3 or could be negative 3. And according to the required in the questions, I may decide which answer I'm going to choose. Now, f of m is equal f of negative 4.5. Where is 4.5? Negative 4.5, negative 4.5 is here. And f of negative 4.5 is equal to 4. So I'm going to say that f of m is equal to 4. And we solved it a few seconds ago that f of c is equal to 4 at negative 3 and 3. So m is equal to 3 or negative 3. Again, all of these values I have figured it out from the graph of the function. Last thing, notice that this function intersects the x-axis at 3 points. This function intersects the x-axis at 3 points. Something while we were solving the last part of the graph, we forgot about it, which is that I have a third point here. One of my students just gave me a hint that I have 3 points intersect as 4. I have the point 3 and negative 3 and the point negative 4.5. So see here is also could be negative 4.5, and here I should put a comma or negative 4.5. Last two questions on the graph. From the given graph, what is the x-intercepts? What are the y-intercepts? What are the factors of f? And this part is very important. X-intercepts are 3 points. 4 at x is equal 4, at x is equal negative half, and at x equal negative 1.5. But the y-intercept, I have only 1 point at y is equal to 1. If you wanted to write this as order pair, it's going to be 4 and 0, negative half and 0, negative 1 and half and 0. And if I wanted to write this point, it's going to be 0 and 1. For number 12, factors is not that different as the x-intercept. But in factors, I'm going to write it as brackets. X intersects at 4, so I can write it as x minus 4. X intersects as negative half. We don't write it x plus half. No, we write it as 2x plus 1. So the 2 go to the x. So we write it as 2x plus 1. And notice that this one is negative, but I add it to the bracket positive. And finally, negative 1 over 2, which can be written as positive 3 over 2. So we can write it as 2x plus 3. So x minus 4, 2x plus 1, and 2x plus 3 are called the factors of the equation. So instead of writing the equation like this, x is equal to 4, I move the 4 inside. So it's x minus 4 is equal to 0. And instead of writing it as x is equal negative half, I put the 2 here, move the negative 1 inside, so it's going to 2x plus 1. And instead of x is equal negative 3 over 2, I move the 2 there, move the negative inside, so 2x plus 3 is equal to 0, and these are factors of the function, and the function here is graphed. Last part for the function notation is how to figure out the values from a given table. So the first form here today was, so the first was how to figure out the values of the function by given functions. Second was from a graph function, and third at the front of you is from a table. If you don't like the table, you can write the table as order pair. Negative 4, negative 1 was negative 4, 0 is with negative 2, 1 is with 0, 2 with 2, 3 is with 4, 4 is with 6, and 5 is with 8. So I'm going to find the answer of the given questions from the table. F of 1, it means 1 with what? So I go to 1 and I can see that 1 with 0. So F of 1 is 0. F of negative 1, negative 4. But what value of y that, what the value of x that y is equal to 8? So I go to the table here. It is here, so I go back. So k here is equal to 5. What the value of c, which is equal to 4? 4, I go here, is 3. But now, what is f of 3? F of 3 first is equal to 4. Then I figure out f of 4. F of 4 is equal to 6. Again, what is f of 0? F of 0 is equal to negative 2. So I am looking for f of negative 2. And f of negative 2 does not exist. So does not exist or undefined into this table. Another question on the same table is to find the x-intercepts. If you remember, we said that the x-intercept is where is y is equal to 0. 1 value. So at x is equal to 1. Y-intercept is at x is equal to 0. And I have only one value, negative 2. So at y is equal to negative 2. What are the factors of f? And we said that factors, I'm going to rewrite x is equal 1 by moving 1 inside So I'm going to write as x minus 1. So x minus 1 is a factor of the function. So we figure out the function notation from three kinds. The first one is from a given function, the second one is from a graph, and the third one is from a